A new paper has just been published that shows that one of the planets orbiting the ultra-cool dwarf star Trappist-1 is incredibly Earth-like, and this discovery has left scientists shocked and scrambling to get more data on this planet. But before we go into what exactly they discovered about Trappist-1e, let's take a step back and look at why Trappist-1 itself is such an amazing system to study. The Trappist-1 system is located in the Aquarius constellation, around 40 light-years from Earth. At the center of the system sits a very unique star. It's a so-called ultra-cool dwarf with a mass slightly larger than Jupiter, but also only about the size of Jupiter. What makes it unique is its extremely low temperature of around 2300 Kelvin. To put that into perspective, our Sun is around 5800 Kelvin. So this red dwarf is more than 3 times cooler. It also has roughly 7 times the radius of Jupiter and is about 10 times less bright. The star was first discovered back in 1999, but it didn't gain much attention until 2017 when it was found to host not 1, not 2, not 3, but at least 7 planets. That's right, 7 planets. And these planets are quite unique because they all orbit within the star's habitable zone, the region around a planet where liquid water could be present on the surface. Now, it should be noted that just because a planet is in the habitable zone doesn't mean that it can support life. It just means that the conditions are suitable for liquid water. But still, 7 planets in the habitable zone is unheard of, which is why it's such an interesting target for astronomers. But there is another reason why Trappist-1 is unique, and that's the fact that it has so many planets. You see, the majority of stars out there are actually red dwarfs. In fact, they make up 75% of the Milky Way's population, so studying them is crucial if we want to understand the big picture. Unfortunately, however, most of these stars have proven to be very difficult to study because they tend to flare up a lot. These outbursts of energy can easily mess up any instruments we point at them. That's why imaging the planets around Trappist-1 was such a huge deal. In 2018, researchers were able to capture the first beautiful images of the Trappist-1 system using the James Webb Space Telescope. The incredible thing about these images is that not only do they show the star and its 7 planets, but it also shows the light passing through each planet's atmosphere. This is because the planets are so close to their star. Light from the star passes through the planet's atmosphere and onto the telescope. It's like having a giant magnifying glass. And this is very useful because the atmospheres of exoplanets are notoriously difficult to study. Normally, you'd need to point your telescope directly at the planet, which is almost impossible given how small they are. But because the planets in the Trappist-1 system are so close to their star, we can basically see their atmospheres without looking directly at them. With this method, astronomers were able to analyze the light that passed through each planet's atmosphere and determine their chemical composition. For example, they found that Trappist-1d and Trappist-1g have hydrogen-dominated atmospheres, while Trappist-1b has a carbon dioxide-rich atmosphere. However, there's one planet whose atmosphere was particularly puzzling, and that's Trappist-1e. In the previous studies, the team couldn't find any clear evidence of an atmosphere. Either the atmosphere was completely absent, or it was covered by clouds, which blocked our view of what lies beneath. This is where the new paper comes in. Using the same transit method that discovered the planets in the first place, a team of astronomers led by David Ehrenreich from the University of Geneva has just confirmed that Trappist-1e does indeed have an atmosphere, but unlike the other planets, it's neither hydrogen nor carbon dioxide dominated. It's actually mostly nitrogen. In fact, it's quite similar to Earth's atmosphere. This discovery was made by analyzing tiny changes in the light curve of the planet. You see, as a planet orbits its star, it undergoes a slight change in velocity due to gravitational perturbations from the other planets. This change in velocity affects the amount of light we receive from the planet, causing the light curve to change slightly. By measuring these tiny variations, the team was able to determine the mass of the planet's atmosphere. They also looked at how much the planet's radius varied over time. All of this data was then fed into a model to determine the density and atmospheric pressure of the planet. So far, so good. But there's even more. You see, when the planet passes in front of the star, some of the starlight passes through the planet's atmosphere and onto our telescopes. When this happens, certain wavelengths of light are absorbed by molecules, leaving dark gaps in the spectrum. By looking at which wavelengths of light are being absorbed, we can tell what kind of molecules are present. In the case of Trappist-1e, the researchers found that the amount of red light reaching us decreased suddenly when the planet passed in front of the star. This indicates that the planet likely has a substantial amount of oxygen in its atmosphere. Now, this alone isn't definitive proof of an oxygen-rich atmosphere. There's a chance that oxygen was released during the formation of the planet and that it's now part of minerals in the planet's mantle. However, the team believes that this is unlikely because the level of oxygen they measured is just too high. Another possibility is that the oxygen could be in the form of a different molecule like carbon monoxide, but again, the abundance of oxygen rules this out. The team believes that the most likely explanation is that the planet has a cloud-free, hydrogen-dominated atmosphere like Earth's. What makes this discovery so exciting is that Trappist-1e is also roughly Earth-sized. We know that its mass is between 0.77 and 1.2 times the mass of Earth. Its radius is also thought to be close to Earth's. In fact, it might even be slightly smaller. The gravity on the planet is also estimated to be very close to Earth's gravity. On top of this, its temperature is also thought to be quite Earth-like, ranging somewhere between 274 and 284 Kelvin or 1 and 2 degrees Celsius. Not to mention that the stellar flux received by Trappist-1e is also very similar to what we experience here on Earth. All of this makes Trappist-1e perhaps the most Earth-like planet ever found. But wait, there's more. The paper also mentions that Trappist-1e could have an ocean. It says that if the planet has a hydrogen-dominated atmosphere, it's very likely that it also has an ocean. And if it has an ocean, then it can definitely support life as we know it. Of course, this is still speculation, but the evidence is certainly intriguing. I know all of this sounds pretty incredible, but it's important to keep in mind that we still do not have any direct evidence of life on Trappist-1e. Everything we've discussed so far is based on computer models and estimates. While these models are very sophisticated and have worked well in the past, they're still just models. With that said, the evidence for an Earth-like planet in the habitable zone of a nearby red dwarf is just too good to pass up. Researchers are now scrambling to collect more data on Trappist-1e, hoping to confirm these exciting results. Luckily, with the James Webb Space Telescope and other powerful telescopes, we'll be able to do this very soon. I, for one, am eagerly anticipating the next chapter in this incredible story. Who knows? Maybe one day we'll find out that we're not alone in this universe. If you enjoyed this video, make sure to subscribe for more videos about awesome discoveries in space. Thank you for watching, and I'll see you next time.